What is HEAPSORT? Let me tell you something about HEAPSORT algorithm. HEAPSORT is one of the best comparison sorting algorithm, which is the runtime is n log n. And today is your lucky day because I will tell you about how the HEAPSORT algorithm works. So first, I will go over the intro to the heap, and second, the max heapify function, and third, BUILD-MAX-HEAP, and fourth is the heapsort algorithm, the main highlight of this video, and lastly is Heapsort Flowchart. Okay, let's get started. So what is heap? Heap is a binary tree and nearly a complete tree. Look on your left. This is an array. We call it an array A. So the index, the first index is value is 16. Index 5 have value 7 and index 10 have value 1. And then if we will sort this, if we will construct this into a binary tree, it will be like on the right side. So we construct it in the index order from 1 to 10. 1, 2, 3, 4, 5, and so on to 10. Okay. So now we will talk about max heapify functions. Okay, let's talk about this. So what is max heapify? Max heapify is called to maintain the max heap property. And what is the max heap property? Imagine once we are at the index I, then the value of the index I need to be greater than its left and right child. Give for example, at index 2, the left child, its value is 4, but its left child is 14, and then the right child is 7. This is violate the max heapify, so we have to fix this. So we will switch the value 4 with the largest value of its children or its immediate children, which is 14, and then we swap this, and as you will see in the figure B, like this. After that, from figure B, we will check the index 4 and its left and right child. Since its value is 4 and then the left child's value is 2, so it's okay. The right child value is 8. So the right child value is greater than the value itself. So we swap it like in the, and then the result will be in the figure C. Then this is the max heapify function. Okay, now we will talk about BUILD-MAX-HEAP function. Okay, let's go. BUILD-MAX-HEAP, there are two main points to remember. First, we convert an array A into a max heap, and by doing that, we call max heapify to all the nodes except leaves nodes. Start from node 7 all the way to node 1 root nodes. So people who don't know what is max heapify, please consult the page 4 to 5 in this video. So for the array A, as you can see on the left, if we want to visualize it in a binary tree version, it's like this. It's been constructed from the index order from 1 to 10. By the way, why don't we call a Heapify function as the nodes 9, 8, and 10, since it's a leaf node, so nothing to do about it. Then we start from node 7. So node 7 have no leaf, so that solves the problem. We go to node 6. Also, they have no, it's the leaf node, so we don't do anything. Then we go to node 5. Since node 5, the value is 16, which is greater than its child node. So this is good. So we move on to node 4. And then the node 4, its value is 2, but the left and right childrens are greater than its values. Then we have to call the max heapify on node 4. So once we call the max heapify on node 4, we altering the node 4 values, and the result is in the figure C. Then we're moving on to node 3, and then we call the max heapify since the left and right children of node 3, the value is greater than node 3. After that, the result of calling max heapify has altered the value of node 3 and then correct all the left and right child to be a max heapify property and well condition. Then we move on to node 2, and then we call max heapify on node 2. Since the node 2 value is 1 and left and right child values are greater than the value, its values, so then we call max heapify there, and then after we alters all the values of the node in that trees, we got the result in figure E on the right to be 16, 14, 7, 2, 8, and 1. So this is a well condition of the heap. Then we move on to node 1. As well, node 1 have values 4 and left and right child have the value greater than node 1. Then we have to alter it by called max heapify. Then we got the final result of the well-defined heap or a binary tree. This is the definition of this is how the function of BUILD-MAX-HEAP work. Okay, finally we will get into the HEAPSORT algorithm. Let's get started. At first, we input the random array 4, 1, 3, 2, 16, 9, 10, 14, 8, and 7, and then in order to make the heap sort algorithm to work, we have to call the BUILD-MAX-HEAP function to build a heap structure based on the random arrays, and then the result as follows. Then after that, we will use the heap sort algorithm to sort the values in array based on the heap structure. From the heap structure, so then we start to swap root node with the last node. So this one, this is 16. Then we reduce the size of array by 1 or discard the last node. Then we call max heapify at the root node. Then the result on the right. Then again, we swap the root node value with the last node, which is 1 to be 14. Then we call max heapify at the root node. Then the result is on the right. This one, the new heapify structure. Then we first swap the root node value with the last node. So 2, and then 2 becomes 10. And then we call max heapify over at the root, and then the result is on the right. So we swap the root node with the last node. That is become 9. Then we call, and then we discuss the last node, discard this node, and then we call max heapify at the root node. The result is on the right. Then from this we swap the root node with the last node, and then we reduce the size of the array by 1, and then we call max heapify at the root. The result on the right. We swap, so this become 2, this becomes 7. Discard the size by 1. Discard the last node or reduce the size by 1. Then we call the max heapify at the root. The result on the right. We swap the root node with the last node, and then we reduce the size by 1, and then we call max heapify. Result is on the right. We follow the same process again. We swap the root node with the last node. So this is 3. And then we discuss the last node, and then we call the max heapify. The results on the right. Same thing, swap 1 and 2. The results on the right. And then after that we cannot discard the array anymore, and our result is on the right. This is the sorted array by the HEAPSORT algorithm. The runtime is only n log n. Now let me talk about Heapsort Flowchart. So this is the Heapsort Flowchart. So start, we input an unsorted array A and then its size. Then we call a BUILD-MAX-HEAP function to construct a heap. And then after that, we initialize the index I to be a size of an array A. Then we have to check is the index I is not in range of 2, 3 to size of an array. If yes, we end the process, and then we got the sorted array. But if it's not, we have to swap A1 with AI, and then we reduce the size of the array by 1, and then we call the max heapify function. Then we increment an index by 1, and then we go over the process again to check if the index I is in the range of 2 or 2, 3, 4 to the size of an array or not. If this statement is true, we end the process, and then we got the sorted algorithms. And then so for people who are interested in Python code, I will try to post it next week. And if you guys like and then don't want to miss out my next video, please like my Facebook page and subscribe my YouTube channel and like my YouTube channel. Thank you so much. And lastly, for this video, I use reference from the book called Introduction to Algorithm, the 4th edition. And thank you for Thomas Corman, Charles Leeserson, and Ronald Rivest, and Clifford Steen. Without you guys, I won't be able to understand the heap sort. Thank you very much for your knowledge, and thank you for sharing this valuable knowledge to me and to the world.